Good morning, everyone. I think we have some known faces. As a part of the steel initiative, steel slag initiative, I would say, we have been meeting some group of people. For them, it will be an update of the status as of today, where we are on the steel slag front. That is number one. The presentation talks about fly ash, but it is only to emphasize or even understand the relevance of fly ash notifications on steel slag. Currently, both fly ash and steel slag are figuring in hazardous waste notification. This notification started in 1989. Even till date, fly ash and steel slag figure in hazardous waste and materials notification. So there is a concern among the Pollution Control Board people that fly ash and steel slag is hazardous. Of course, in the note it says that low impact materials like fly ash, red mud, steel slag, pyrometallurgical slags are to be examined, and Pollution Control Board will come with guidelines. So to that extent, there is a guideline which was issued in December 2021. I will show you that. So today if it has come for fly ash, tomorrow it will be for steel slag. So with that context, I am going to present the current status of research being conducted in the country and where we are. That presentation will be done. Yeah. Now, everybody is talking about similarities. So for the purpose of understanding and also the problem that the industry will face is given here. Waste by volume in India, obviously it is the fly ash, which is a major issue. And number two is steel slag. So though there are some material like red mud and also the tailings, they are necessarily not material which are wastes. They are of uniform composition and probably are the raw materials for tomorrow, not of today, but maybe of tomorrow. Tailings are not contaminated. Red mud is not contaminated. Steel slag is contaminated. That is the reason why people refer steel slag as a waste. Now if you look at, they are low value. I mean, hardly you get any money out of fly ash. Large volumes, we need policy initiatives. Just by telling that we are going to give steel slag or in a form that it is required doesn't help us. We need the support of the government. We'll discuss that also later. Volume, it is large in volume, 1 million tons. Major usage of fly ash is in cement and construction, and steel slag, it is basically going to be in construction, the way we are working towards it. Bulk density and major component is fly ash obtained as produced. The difference between fly ash and steel slag is fly ash can be sold as produced. Steel slag requires a lot of processing to make it suitable for the consumer. So there are some fundamental things I think you are all aware, but I think there is need to understand the implications of this. Incidentally, my domain is environment and not neither civil or structural and other things. So if you look from a production process point of view, what we have is a product and a byproduct. We also have wastes. So these are the ultimately, if you take the total ecosystem, so this is the definition. Products and byproducts are those materials which have a unique technical specifications. Like a BIS standard or a ASTM standard, you are able to sell because the customer should know or would like to know what is it that I am getting. And what is most important is the technical specifications. If there is a technical specification, the product is understood by both the people, a transaction can take place. In cases where the material doesn't have any specification, there should be a MOU with the person. For example, I am ready to give you a material and this is going to have this composition. If somebody agrees, fair enough, there is a deal which is possible. But when you come to waste, things are slightly different. We have norms. Like pollution, sulfur dioxide should not exceed this much. Effluent should not be discharged outside the limits. We are going to have some norms even for carbon dioxide shortly. But what has not come under regulation till now is the wastes. Waste from the steel plant, which is the steel slag. A blast furnace slag was an issue long back, now it is a proven material which is used in cement making. The most important thing that we need to realize from an environmental point of view, the polluter pays. That is very clear, and I think most of you are also aware of this, but implication you need to understand. Okay. And there is something which is now being talked about, extended producer responsibility, EPR. Meaning, even if the ash was given to somebody, he made a brick out of it. If there is an environment contaminated, noted after 15 years, we are responsible. We as producers are responsible. If something happens, we are responsible. If the brick fails, we can be made responsible. So we need to understand the extended producer responsibility remains with the producer. And whatever way you give it to anybody, if something happens, we are responsible. The responsibility cannot be shifted. This is as per the environmental regulations or issues. Most important thing is, if what is required is a technical specification between two people, between two organizations, or whatever it is. Unless you have a correct technical specification, you cannot be selling anything to anybody. So today, ash is available in Delhi, it has a value. But you come to Orissa, Chhattisgarh, where plants are producing 10,000 tons per day of fly ash, there is no usage. So while Delhi people are lucky, here there is no way they can use it. And I'll get you to this now. This is very common sense, but still I would like to reiterate. Waste is heterogeneous. Okay. But it is uneconomical to further process it. That is the reason it is a waste. In some countries, even the good material stored for over a longer period is also called waste. For example, somebody was talking about making fly ash bricks. Fair enough. It is in Delhi, it is possible. In Mumbai, it is possible. There are people to buy. How do you make fly ash bricks in, say, Orissa and expect it will be sold? A 10,000 ton, for example, in Orissa, there are many power plants which are generating 5 to 10,000 tons of material, ash material. Where do they sell? Who is going to buy? If you make fly ash bricks, you are going to make a mountain of fly ash bricks. Is that a solution? Not a solution. So, these are low value, large quantity materials. Need a government initiative. Without that, there is nothing much going to happen. And now, when you come to fly ash is a product which meets IS specifications 3812. And it is a product that should be having a saleable value. It has a saleable value. Like 700 rupees vis-a-vis 120 rupees for the bottom ash. But fly ash, if you look at how many cement manufacturing units are there which can consume all the fly ash. If you are talking about 100 million ton, it's a very good resource. But we need government initiatives. Why can't they mandate all cement plants? You don't make OPC, you have to take fly ash from the power plants. So that policy initiative itself will make fly ash a very good resource material. So what is required is the waste we need to convert it into secondary minerals, secondary raw materials. So what I'm talking of is the source of secondary raw materials. For example, fly ash is a positive material, good material. Bottom ash, if collected dry, can be used as in cement making. But pond ash and mound ash, basically the one which are contaminated, truly are not the material for use in cement. Maybe people can have views on that. But ultimately it ends up in backfill application, landfill applications. Now coming to steel slag, if you look at steel slag, there are many types of processes which are there currently. In India we have BOF, basic oxygen furnace, A slight variant is the electric energy optimizing furnace, a zero power furnace, electric arc furnace, cone arc furnaces. These are the types of primary steel making operations which take place. We also have other types of slags like desulfurization slag, LHF slag, RH slag, CAS-OB slag, and there are many types of slags which are generated, and they are all loosely classified as steel slag. So we need to understand that all this come under loosely they are called steel slag because they are produced in the steel melting shop. And that's the only reason. Though the hot metal pretreatment slag is not the real steel making slag, but loosely it is considered as a steel slag. Now, coming to the process, I think everybody is aware of it. Typically, the desulfurization, which is a hot metal treatment, the generation is around 15 to 20 kg per ton of crude steel. In BOF, it is 150 to 180, depending on the process and the impurity that you have. Electric arc furnace, it is slightly higher, so 180 to 200. This is the range of slag generation which take place. Besides that, we have post-treatment or the secondary metallurgy slag, LHF, then we have silicon killed, aluminum killed, so many types of. All this put together is called steel slag, which is the main reason why we are not able to effectively utilize it. Now, this is the recent guideline which has come from Ministry of Environment on fly ash. As I told you earlier, what happens today to fly ash, tomorrow it is going to happen for steel slag also. Now, this notification took almost 20 years to finalize. The first notification came sometime in April 99, and the last notification which has come is in 31st December 2021. So it has taken 20 years for the notification, meaning for the industry and the thing to agree. So as per this notification, you can say the guidelines. What is required is permitted usage is 10 numbers. It says the fly ash from the coal ash or bottom ash can only be used in these applications. And it also mandates that you have to give it free up to 300 kilometers. So look at the cost. For example, even at 5 rupees per kilometer, 300 kilometers is 1500 rupees of truck transportation. So this is a negative cost for the producer. Imagine you can look at this condition when it becomes applied for steel slag. Not only we have to process steel slag, we have to incur a cost of 1500 rupees per ton because we have to give the material free of cost. So this is the kind of an implication that we are looking at in the future. Because now the Ministry of Environment is very clear, no more goading, no more discussions, start doing the implementation part. Now, the second thing is, you have to give it free, but if you don't give it free, there is a penalty. Penalty is here at the bottom, 1000 rupees per ton if you don't use it. If the ash utilization is not done, this is for fly ash, I mean the ash actually, not for steel slag. For people from steel plants should think that maybe next year we will have this similar notification. If it is not consumed, then we have to pay a penalty of 1000 rupees per ton. That is number one. But government also has been done a good thing. But if the consumer is not ready to take, then he has to pay a fine of 1500 rupees per ton. Meaning which, for example, National Highway is going to build a road. They will come and ask us, can you give me so much of ash? Okay, we agree. And if he doesn't take it, then he has to pay a penalty, which is a good, right thing. That means a material, when it meets a technical specification, is a product. We need to understand that. Any waste, if it is consistent, meets a technical specification, has a BIS standard, has an IRC standard, it becomes a product. It is no more a waste. And a product has unique specification, unique value also. Now, earlier there were chances that people used to take fly ash and dump it from evacuation point of view. For them, the truck transporters, They cannot throw fly ash anywhere. If they are seen, they have to pay a penalty of 1500 rupees per ton. So the government has taken the aspect from both point of view. Now the real issue that happens with ash and also the steel slag would be, what happens is, if there is no specification, if I am going to sell steel slag for NHA, they will say, no, we have to have a standard. If there is no standard, then we can't accept this material. National highways are project specific. That means a road from here, 100-kilometer road is one project, another 100 kilometers is another project. So when the project specific allocation comes, it becomes difficult for us because the generation is continuous, whereas the consumption is periodic. How are you going to manage this major issue? I mean, I am throwing open this challenge to the steel makers. For the fly ash people, in the next 1 or 2 years, we will come to know how this guideline will pan out. Because we have been consistently, the producers have been not agreeing to this. But we have now a notification notified. Okay. Now what I have marked here is the green color is the product which meets a particular specification. For example, if the fly ash is going to be exported to say Bangladesh, then there is a specification which we have to meet. It is not that anything and everything can be sold as fly ash. So when you have a specification, agreed norm, then there can be a value. If there is no specification, it is a waste. So the most important thing is we need to have standards. And steel slag has not been unfortunate enough to have such kind of standards. Though there are international standards, but in India, there are no standards. Today, we have many people, Tata Steel, JSW, so many people we have approached national highways, rural roads. They say, wonderful, you give me steel slag. But it has to be at 1/4 or 1/3 the price of natural aggregate. So natural aggregates sale between 300 to 900 rupees. If you are going to say give it at 100 rupees, it doesn't even meet the transportation costs. So this is one of the major reasons why steel slag has not been utilized. Emphasizing, there is no specification for intended application. It is there in other countries, but in India it's still developing. Now we all know that aggregates, steel slag, the major utilization can only be in the form of aggregates. If you look at the aggregates, they are basically coarse aggregate, the fine aggregate. Fine aggregate, for understanding, it is sand, like replacement of river sand. Coarse aggregate, anything more than 10 millimeter is coarse aggregate. And in India, the consumption of aggregate is more than 1.5 or 2 tons per capita. You can imagine our population and you can imagine how much of aggregates are going to be required, are being consumed. Okay. Now, the major applications is the pavements, concrete, mortar, ballast, gabions, there are marine applications, tetrapods, embankments. These are the major applications where civil construction is involved and where steel slag can be made as a useful material. From here on, it's only about steel slag. Okay. Now, one of the major areas of consumption, aggregate consumption, is going to be in the marine areas. Can you just see this figure and see what is the potential that is available? There is a Sagarmala project of the government of India, where huge requirement of materials are required. Several small and minor ports are being developed, which requires breakwater. All this is the basic plain concrete, which is M30. M30 material. If steel slag can be used in this application, we can convert all the steel slag into this material, and they will not find any more steel slag lying in the plant. So, marine application is a major area. I don't know whether we have really missed the bus so far as the highways are concerned, because people are constructing at highways, at 10 kilometers per day. At 10 kilometers per day, I was told that 1 kilometer of road will require around 20,000 tons of slag, aggregate. So NHAI is consuming 70 million ton of aggregates every year. Where are they getting it from? By cutting mountains and cutting rocks. Is it a correct thing to do? No. But if they utilize steel slag, I can guarantee you within 1 or 2 years, not a single ton of steel slag will be there in the country. We need those kind of initiatives from the government. This is basically my perception or my understanding of where we are in terms of the research that are being conducted by Tata Steel, JSW, ArcelorMittal, so many other people. Now, there are some usages which are incidental because it is not sold. We have to make somehow usage of that. I have divided it into internal consumption, the external consumption, and the future things. Now, internal usage after metallic removal, that is the steel slag that we are worried about. It is being used in sinter making as a lime substitute. No value addition because you are heating again the steel slag having inerts up to that temperature. The real advantages are not commensurate with the usage. Now, reuse of slag from HMPT and secondary treatment, that is more or less understood, and it is being done again through the sinter plant. We need to identify the secondary sources of the small slag materials. For example, there are 5 types of slag which I told you, primary and secondary. Secondary also many types. It is physically not possible for any industry to set up 5 processing facilities, stack everywhere and then consume it. So as a result, people of my age, we thought that it is better to dump it as a waste. Because there is no usage, that is the reason why we have created a problem which you could have avoided long back. Internal roads, extensively steel slag is being used. In Vijayanagar, in Dolvi, even in Jharkhand, in Jharsuguda, we are using slags for internal roads. But what can be used by us is not standard. It is something we agree. If it fails, we will repair it. But when National Highway wants, they expect that it should run for 15 years, 20 years. Fair enough, it's a good thing. But if you go to Mumbai to Goa, that road is being relaid every year. So this year they make the road, next year it gets spoiled because of the heavy rains. So they remake it. So this is a perpetual process. But still, right now I think we are laying one portion in that particular area. Now, external usage, that means outside our plant. It can be major usages can be in flexible payments, which is bituminous roads. Rigid payments, it is the concrete roads. So you look at the codes which are necessary to be included. So if IRC allows us usage of steel slag in bituminous roads, then you can use it. It has not been done, so there is no usage practically. If it was introduced, studies are going on. What I understand is on the electric arc furnace slag, there is some silver lining. It is generally agreed that electrical arc furnace slags are not expansive in nature. And being the basicity being low, they are not expansive. And they pass the expansion test, whatever is the limit set by this. So they are now, the understanding is that electric arc furnace slag can be used after removal of metallics. This is a good thing. I would say this is a major advantage. Even Mr. Ojaji will discuss with you regarding the steel slag as sand. Okay, so that also we have found that it is as good as sand, or in some properties it is better, but there are some issues which needs to be resolved. So once you have a rigid pavement, concrete roads, then we need introduction in 2 codes. One is in IRC, again second in BIS, because the domain of concrete belongs to BIS. IS 383 is the basic standard. So in that EAF, more or less 80% studies have been completed. We need to maybe another 6 or 8 months to ensure that EAF slag is accepted both in bituminous and concrete layers. So maybe in 6 to 8 months, we will have a notification, probably by both VIS and this one, where EAF slag can be utilized in roads, both bituminous and this thing. But in BOF, there are issues that needs to be resolved. Basic issue is, of course, the expansion. Then marine construction. Marine construction needs M30 concrete, so we need a BIS code to be introduced. Then in addition to that, we need to establish eco-toxicity. That means if that concrete is exposed to marine environment, will there be any toxicity limits? So that JSW is getting it studied through IIT Mumbai. I think that report should come in a matter of another 1 year. So that will open up a huge application for steel slag in marine areas. So we are still on that. EAF comfort is there. BOF still doubtful. Ecotoxic studies are started. This is the basic status as of today. Mortar and pavement, we don't see much of an issue because IS 383, once it is certified, then probably mortar and things will become relatively easy. Now in other applications, I mean what is going to likely to happen in future. Using composite cement is already permitted. Steel slag in composite cement. Fertilizer and soil improvement, a lot of work is being done. We will have a speaker who will discuss this. Carbon sequestration. There is a potential of absorbing 0.2 ton of carbon dioxide per ton of slag, which ultimately is going to make some impact at some point in time. But as of today, it is not practiced, but this is an area where some amount of research is required. Carbonated bricks. There are many people throughout the world who make carbonated bricks. After carbonation, the bricks become very strong, and they are an excellent material for civil construction. And marine blocks for carbon dioxide capture. That means if you make bricks, large bricks out of steel slag and dump it in the ocean, it will help in sequestration of carbon dioxide. Recovery of gypsum and PCC. PCC is precipitated calcium carbonate. There are some research papers who say that it is feasible. And the ultimate one is slag to clinker. I mean, if you look at the ternary diagram of steel slag, other than iron, it fits exactly at the clinker point. And it also gives around 15 to 20 kg of hot metal for usage. It is still in theory. It is possible to separate it, but the amount of cooling which is required, it is not technically feasible as of today. I think we may get some information from my colleague of mine who is in Praveen. So as of today, it is not there, but this is the ultimate solution for steel slag, being used as a clinker, the high value added material. Now, again the same thing, EAF Conox slag, they are electric arc furnace slags. It is suitable for pavements, both bituminous and rigid. Maybe after the 8 months when the notification comes, it can be used. Test sections are laid by CRRI in Surat, and currently they are doing one in Dolvi. By this month end it should be over. That's a concrete road, and followed by a bituminous road, national highway. And this is suitable as construction aggregates. I mean, in general, the perception is this. Additional tests are being done for confirmation and coming out with a standard. BOF slag has an issue. I mean, we are not able to convince the BOF slag. Acceptable for sub-base and base applications in pavements. That is because this is an unbounded area. Even if slight expansion takes place, it can be accommodated. But in bound application, concrete, it is not permitted. No other country also has permitted use in concrete. So it is only in the base and sub-base. And one thing is, weathering for the coarse aggregate is a must. Without weathering, you cannot sell. That's very clear. And our estimates of weathering is at least 1,000 rupees per ton. I mean, this is, there are various methods of weathering. the estimate which we feel is likely to be right is around processing cost for weathering of coarse steel slag is going to be 1,000 rupees per ton. Now, BOF slag, that is one of the reasons that in JSW we try to come out of this problem. If you do the weathering, then you have a cost. And if you have to give it a 100,000 rupees penalty and all that, I mean, it's not economical. So one development or initiative that we took was you keep on crushing steel slag up to say 5 millimeter. It is to be understood that free lime is not homogeneously present in steel slag. It is in pockets. So once you crush that material, the free lime gets separated out in the form of fines. And by year classification, if you remove those free lime, that is a material suitable for fertilizer, soil conditioning, soil improvement, and also for cement making, because it is rich in lime and it is less than 150 micron in size. So this is the exercise that we have started, but though the properties are fine, these issues that we need to resolve. Whether even after making it as fine aggregate, does it expand or not, is something that we need to definitely come to some conclusion. The advantage of doing fine sand is because natural sand is banned, so you get a premium on sand, this material. So I was just discussing, in Mumbai, the sand sells at 2,000 rupees a ton, whereas coarse aggregate sells at 900 rupees a ton. So that by spending 1,000 rupees on weathering, and if you want to give coarse slag to somebody, you don't get money. And one thing I am clear, I think most of you are clear, what is economically not sustainable is not environmentally sustainable. Whatever government may say, people may do it, people may follow. Within us, nobody will agree. For example, if somebody says you spend 2,000 rupees and then give it to somebody at free, I don't think it's a case for usage. Today or tomorrow it is going to fail. Now, there are some issues that we need to address. We are in discussion. Test method for volumetric expansion of fine aggregate is not there anywhere in the world. It is there only for coarse aggregate. Fine aggregate, we are not aware. ASTM standard, Japanese standard, European standard, they all talk of coarse aggregate, between 0 to 35 mm. So for fine aggregate, when we make sand, obviously it doesn't fit in that, so we need to establish this procedure. And most important thing is, what is the limit up to which we can allow? ASTM allows up to 0.5%, and Japanese standard allows to 0.5%. And as Mr. Atano was telling, no amount of weathering, we have been able to achieve that figure of 0.5%. I mean, these are the issues that will make BOF slag a material of problem. Maximum limits, obviously, it is to be finalized after the test procedure is identified. Now, what is the thing which a steel plant should be looking at? Give me for 2 minutes, I'll close. Yeah. What is that as a steel maker? Where is your timelines? What is that we must be doing? First thing is, there are many people who ask us, oh, a lot of slag is lying in my backyard, can I use it? No. The slag was dumped because it has no use for that. It is mixed and it is lying there. This material cannot meet any specification. A waste is a waste. So we need to understand that I cannot use this slag, because still management of many steel companies think that it can be used. Why can't we use it as a sand material, material for road or other applications? It is not done. So I think that myth should be taken very seriously. What is lying as a waste is a waste. It cannot be a product. Only fresh material can be a product. Second is segregation of primary and secondary slag processing. One of the big mistakes that we did was we combined all the steel slag and dumped it together, and each slag, like LHF, silicon kiln, aluminum kiln, they are all different in composition. By mixing it together, we have created a waste. Now, earlier we start separating, we have a value. In fact, I was assumed that in JSW it took almost 4 or 5 years for people to even realize that yes, we need to separate. Because steel makers are not interested in sale of slag. They will say that, oh, it was 20 ton hai, 30 ton hai, we will go and dump it somewhere along with the steel slag. Once you dump it as a mixed slag, you have created a waste and not a product. Now, the next thing which is far more important is, what do you want to produce and sell? You want to sell as a coarse aggregate or a fine aggregate. As I told you, that the cost differential is huge. So we need to understand what I am going to produce. Like in case of, for example, in near Jharsuguda, sand prices are low. It makes sense to produce coarse aggregate. Whereas in Mumbai or in other places, the slag rates, as I told you, is close to 1,500 to 2,000 rupees. It is always better to go for fine aggregates. So that choice you need to make and start supplying after the IRC and BS codes are issued. Same thing for EAF slag. I am hopeful. In fact, the research community has a view that it can be used without processing. Without processing means, I will tell you, a lot of benefits will come out of optimization of your lime consumption. Because more lime you add, more waste you are creating. Now, I would assume that EAF slag maybe in another 6 or 8 months can become a product with standards. So if somebody is planning for, if you are with a EAF who are making steel through EAF route, this is the time to start thinking, what should I make, where will I make, making investment. So this is the time to start for EAF slag people, not for BOF, not as it. BOF slag, we have an issue with volumetric expansion. The limits are not known. Because when the limits are not known, what is that you are going to try? For example, if it says 1%, we can try to reach 1%. If it is 0.5, we can try to reach 0.5. If it is not there, so we don't know what to make. Unless that is decided, we cannot be looking at. But BOF slag weathering, everybody knows. The technology is known throughout the world. In greenfield site, it is the Steel technology, the recent modification. Then silicon injection or the sand injection in the hot stage will bring down the basicity. We have not seen it in India as of now. And steam box technology, which is used in China, which we are implementing in Dolvi shortly. Maybe by November we should have the results of this particular studies. Ultimately, the brownfield site, like what we are all in, it is only the open or the closed steam aging will work. Because there is no space to adopt any of these technologies in the existing slag yard. So we need to take it out. Once you need to take it out, you have to have a separate processing, which only these two can provide it. Then after these are ensured, because this is a major doubt, resolution of this issue is required, then only BOF slag can be used as a product. Till such time, we do not see any standard coming. And in India, without a standard, no, it's a waste. In fact, bulk of our application are the consumption. Who is the consumer? It is the NHAI, PWD. It is not even sufficient that we get a code. It has to be entered in the schedule of rates of the government. If it is not in the schedule of rates, nobody will accept. So getting code, getting a code for a product itself takes time, and further it takes much more time to getting it introduced in SR for individual states. I am through. But government can make a difference. I mean, this is an important slide. I would like you to think over, and I think we need to work on this. That is most important. Voluntary commitment. For example, when I say that steel slag is a good material, after the standards are established, we are making a product. Now we need the government to say, yes, we are going to buy this material. As I told you, NHI is consuming 70, 80 million ton of natural aggregates. by cutting the mountains and this thing. Why can't they take a stand? I will consume only 5% of this thing will be our artificial aggregates. Is it not their job? Is it not their voluntary commitment towards the country? So they need to make a commitment. I will tell you, if they say 5% of my overall national aggregate requirement, I will use 5% of industrial waste. I will tell you, within 1 or 2 years, you will not find any steel slag. And we are not discussing the advantages of steel slag. And I am damn sure that within 2 years, this steel slag will become a material of choice. They will give you a premium for this. But as of today, there is no material, so people don't understand the value of steel slag as aggregate. So this is the first thing which we need to tell the government. Please ask the major consumers, NHAI, PWD, Irrigation Department, at least let them commit 2%, 5%. That itself is good enough. See, 80 million ton of NHAI consumption, our generation is only 10 million. That's only 2 months requirement in a year. Second is, they need to pay a premium for the artificial aggregate. It is not that we are getting a material as produced that we are giving. No. We are producing a product. We are producing after processing. And we are producing it to a particular specification. So when it is there, they should give a premium because they are using natural aggregate. They will help the environment in using artificial aggregate. That is number one. And there is a very excellent example. 10 years back, the government is still having that policy of renewable purchase obligation, RPO. In that RPO, it has been mandated that you have to use 10% of electricity consumption from solar and so much from wind. At that time, the rates were 8 rupees, 9 rupees, 10 years back. So now, people had to buy at that rate, premium. What I'm talking about the premium. Now the solar prices really picked up. It is a success story. It's a global success story. As a result, we are able to make it. So we need a premium on the slag steel that we are going to produce and market it to a particular standard. And this is another thing which we share with the ash manufacturers also. There is no point in telling that you have to use all things, everything, always. Ultimately, when you start recovering, there will be a end of process. I mean, the process has to end somewhere, and the waste, they should allow us to make a cap of it, like they were telling our biological parks. They have done. Juxalemuk dump, you see. I mean, if you see the Juxalemuk dump, what it was and what it is now, it's a big difference. Where is the point in asking that to be utilized? Legacy ash, 10 years back, you had to utilize. These are all wrong precedents, wrong policy directives. Because the committee which makes the directives, nobody from the producer is involved. Okay. Thank you very much.
Thank you so much, sir. Kindly stay back on the stage for a token of appreciation. I would request Dr. Sanjay Kumar to present our speaker with a token of appreciation. Thank you so much, sir. There's a slight change in the schedule as some of our guests have their flights to catch. So I would now request Mr. Bhupendra Singh, scientist IARI, who will talk about value addition of LD slag.